Hello student, welcome to our third lesson. In this lesson, we are going to look at the area of a circle and also the area of a sector of a circle. So, we have a circle that is drawn on a graph paper. You can as well do that when you are listening to this. Make sure that you have a graph paper, then draw a circle on that graph paper. We want to see how we can be able to get the area of a circle. Now, the area is estimated. I want you to estimate the area by counting the number of squares that are enclosed by your circle. After counting the area or the number of squares, then you estimate the area, and that area is divided by the square of the radius. Remember this, if you want to get the square of the radius, you have the center of your circle, you count the number of squares that are representing the radius, and then you get the area, you divide by the square of the radius, and then you tabulate your results. You can start with the circle whose radius is 3 centimeter. You estimate the area, then you divide by the square of the area of the radius. That is, if the radius is 3, you square this, that will give you 9. Then the estimated area is 29, you divide by that, you get the value here. So this column, the last column, is giving us the area divided by r squared. You proceed with another circle, you draw another circle of 4 centimeter. So 4 centimeter implies that the square of this will be 16. Then the estimated area, this estimated area is found by counting the number of 1 square or 1 centimeter squares that are enclosed by your circle. So again, you divide. We did this and we found 3.06. Then for 5 centimeter, we found that it is 3.08. For 6 centimeter, we found that it is 3.14. So what we are interested on is this column. If you look at this column, it is 3.22, 3.06, 3.08, 3.14. So this column is almost, or it is approaching a constant. And a constant is a value that is not changing. So it implies that this constant is supposed to be same for all the circles. Therefore, from the results, it is realized that a of r squared approaches a constant, and that constant is what we call pi, and its value is 3.142. That is correct to 3 decimal places, or in fraction form is 22/7. So this is now the pi that we are going to use. Therefore, as we have seen, because we have seen that a divided by r squared is pi, therefore we can say that the area is pi r squared. And this is the formula of getting the area of a circle. So we can look at an example. Calculate the area of a circle whose radius is 3.5 centimeter. So we proceed as follows. We have our formula. We substitute the values, that is 22/7 times the radius squared. So by so doing, you get that the value of the area will be 35.5 square centimeter. Make sure that you multiply. You can cancel this, you get 0.5, then you multiply 22 times 0.5 times 3.5. You will get the same value, 38.5 square centimeter. Remember, in mathematics, you need a lot. You need to practice a lot. So when you are listening, make sure that you are also writing down and calculating the values. So example number 2, calculate the radius of a circle whose area is 44 square centimeter. We proceed as follows. First of all, we have to write the area. That is the formula. We always start with the formula. Now we have been given the area, we substitute. We need now to get the radius. This should be r squared. So for us to get the r squared, you multiply by the reciprocal of this. In fact, we want to eliminate this term on this side. So we multiply by 7, then we divide by 22. And by so doing, by 22 you get 1, by 22 you get 2. So it will be 2 times 7, you get 14. So r squared is 14. So the square root of 14 will be 3.7. You can be able to get the square root in using mathematical tables. Remember the topic of squares and square root. You can get it directly from mathematical table. So you get that r is 3.7 centimeter. That is our radius. Then question number 3. A circular metal sheet of radius 2.8 centimeter is cut out from a rectangular sheet measuring 7 by 9 centimeter. find the area of the metal left. So remember, we have the sheet that is rectangular. So the area left will be the area of the rectangle, this one, minus the area of the circle. So the area of the rectangle will be 7 by 9, but the area of the circle will be pi r squared. That is 22 over 7 times 2.8 times 2.8. This, when you multiply 7 by 9, you get 63. When you multiply this, you get 24.64. So by subtracting, you get that the area that will be left will be 38.36 square centimeter. After that, we move to the area of a sector. In our previous lesson, that is, in our previous topic, that is the topic of length, we found that a sector is a region that is bounded by two radii and arc. So two radius or two radius, we have radius AC and CB, and then an arc. This gives you a sector. So we have minor sector if this arc length is less than a half of the circle, and this other one will give us the major sector. So this arc subtends an angle at the center, this one, and this arc that is the major sector given by the major arc is subtending an angle at the center. Now, to get the area of the shaded part, this part, that is our minor sector, we proceed as follows. So the area of the whole circle is given by pi r squared. We have found that in our explanation area. But now the whole circle subtends 360 at its center. That is the whole circumference. It subtends 360 at the center. So it implies that 360 corresponds to 360 over 360 times pi r squared. It corresponds to, if you cancel that, it corresponds to pi r squared. That is 360 degrees corresponds to the area of the whole circle, which is pi r squared. So it implies that 1 degree corresponds to 1 over 360 pi r squared. Therefore, 60 degrees corresponds to 60 over 360 pi r squared. What does that tell us? That if we are able to get, if we have the area that, or the angle that is subtended by the arc, and now you want to get the sector, the area of the sector, you just need to get the angle subtended at the center. You divide by 360, then you multiply by the area of the whole circle. So in general, we can say that the area of a sector, if you have this sector with the angle theta that is subtended at the center, it will be given by theta over 360 times pi r squared. This is now the area of the sector. We can have an example. Find the area of a sector of a circle of radius 3 centimeter if the angle subtended at the center is 210 degrees. So we proceed as follows. We've seen that the area is theta over 360 pi r squared. So we replace our theta with 210 and our radius with 3 centimeter. So, and then you multiply. And when you multiply, you find that the area of that sector will be 16.5 square centimeter. We still have another example. The area of a sector of a circle is 35.5 centimeter squared. Find the radius of the circle if the angle subtended at the center is 90 degrees. So we proceed as follows. We first of all write our formula. By writing the formula, the second step is to write or to substitute the values in our formula. We have the area that is 38.5. We have the angle that is 90. So we want to get the radius, that is our unknown. So by so doing, we can now make r squared the subject of the formula, and we do that by multiplying through by the denominator and then dividing by the numerator. So we multiply by 360 times 7, and then we divide by 90 multiplied by 22. You can cancel out those values that are cancelling out. For example, you can say that by 90 here, 1, by 90 you have 4. And then when you multiply all those, you find that r squared will be 49. So our r will be the square root of that, which is 7 centimeter. Then another example. The area of a sector of a circle of radius 63 is this one, 4,158 square centimeter. Calculate the angle subtended at the center of the circle. And this one you're also told to take pi as 22/7. So we proceed as follows. First of all, we always start by writing our formula. After writing the formula, we substitute the values that are given. In this case, we are given the area and we are also given the radius. So our task is to get the value of theta. So after that, again, we make this theta the subject of the formula by multiplying by the denominators, that is both sides. You multiply 360 by 7 and then you divide by the numerator, which is 22, then by 63 by 63. And when you divide by 22, you get 1, by 22 you get 40, you get that. You are dividing, you get all those values, you get that. You find that by dividing all these, you find that this will be 3 times 40, which is 120 degrees. So the value of theta is 120 degrees. From there, we still have another example. Find the area of shaded region in the following figures. We have our first figure here. We want to get the area of shaded region. If you look at this figure, this is a square. Then inside the square, we have the circle. So to get the area of the shaded region will be the area of the square minus the area of the circle. So the area of the square will be 2.8 times 2.8, whereas the area of the square of the circle will be pi r squared. And because this is the diameter, that is 2.8, then the radius will be 1.4. So it will be pi 22/7 times 1.4 times 1.4. When you multiply this, you get it is 7.84 minus 6.16. When you subtract, you get that the area of the shaded region will be 1.68 square centimeter. Then part B, we have this one. We want to get now the area of shaded region. If you look at this one is now a rectangle, but now we have two sectors at the corners. So first of all, we get the area of the rectangle. Then, because the sectors are the same, we get the area of one sector, we multiply by 2, and then we subtract. So we proceed as follows. The area of the shaded region will be the area of the rectangle minus the area of the sectors. Now, the area of the rectangle will be 14 by 7, and the area of the sectors will be 90, because this angle is 90 pi r squared. So our pi is 22/7, our r is 2.8, so it is pi r squared. Then we multiply by 2 because we have two such sectors. And by so doing, you get that this will be 98 minus 12.32. You get that the area of shaded region will be 85.68 centimeters squared. From there, we have the assignment. Again, you need to practice a lot and come and do the assignment. Teach your peers so that you can retain that knowledge for a longer time. So thank you, and let us meet in our next lesson.